Dear friends, in this video we are going to discuss about various methods available for recovering the waste heat from thermal power plant, boilers and other heat sources. So thermal storage is a very important concept in the field of mechanical engineering. In the earlier video I have discussed about the importance of residual or waste heat recovery. So in this video we are going to discuss about different methods available for recovering the waste heat from various sources. So there are four methods to recover the waste heat or residual heat. One is conventional steam power plant, that is Rankine cycle. Everyone knows about the Rankine cycle. It is a basic cycle of any steam power plant. Second one is organic Rankine cycle. It is termed as ORC plant. Third one is ammonia water system, that is Kalina and Neogen. There are two systems under ammonia water systems. Last one is thermoelectric power generation. So we are going to discuss about methodology, advantages and disadvantages of each system. That is conventional steam power plant using Rankine cycle, organic Rankine cycle, ammonia water system. In ammonia water system, we are having two types. One is Kalina, another one is Neogen. Fourth one is thermoelectric power generation. So let us move on to the first type, that is basic type. The steam Rankine cycle is simply called as SRC. Here the most common working medium is steam. Steam is used as the working medium which is generated from boiler, steam generator. So we are getting the exhaust heat from flue gases from the furnace, and it will go to the heat recovery boiler. That is, it will recover the heat, waste heat, which is coming out from the boiler furnace as a flue gas. That hot flue gases is used as for heating the water to steam. So the working fluid here is a steam. The high superheated steam will enter the turbine and it will generate the power. After generating the power, after doing the work in the turbine, the expanded steam will enter the condenser. When it enters the condenser, it will release the hot water. If you want, we can take the hot water out, that is heat out. That can be utilized for some other purpose. In process industries, we may need heat. That heat can be withdrawn from the condenser, and the remaining liquid will be hot liquid will be pumped back to heat recovery system, and it will be converted into steam, and the cycle will be repeated. This is called steam Rankine cycle, the first method, the conventional method. The second one is organic Rankine cycle. This is a different cycle. Here the working medium is butane, freon, propane, ammonia, that is natural working medium, which are having a basic properties like low boiling point, high vapor pressure, high molecular mass and high mass flow rate compared to water. So these are the essential characteristics of the organic Rankine cycle working medium. So working medium here, freon, butane, propane and ammonia, which are having the above said important characteristics like low boiling point, high vapor pressure, high molecular mass and high mass flow rate than conventional steam or water. Here the liquid generate waste heat from as low as 300 degree Fahrenheit, whereas the steam systems are limited to heat sources than 500 degree. If it is 500 or above only, we can recover the heat, whereas the organic Rankine cycle will recover the heat even at 300 degree Fahrenheit. That is the advantage of having organic Rankine cycle power plant. It is mostly used in geothermal power plants and pipeline compressor heat recovery applications, whereas the Rankine power cycle is used in conventional thermal power plant or steam power plant, whereas ORC, that is organic Rankine cycle, is used in geothermal power plants. Here also the layout, which are very similar to the basics of Rankine cycle. Here also we have the heat source. It may be from various sources. and it will go to the turbo generator for generating power. From condenser it will go to the cooling tower, and the remaining will come to feed pump, and again it will go to the boiler. So this is called organic, which is used in geothermal and pipeline compressor. Third one is ammonia water system, that is Kalina cycle. Here we have different heat sources, which is complicated than organic Rankine cycle, that is ORC. Here the mixture of water and ammonia is used as a working medium. In the first case, water or steam alone is used as a working medium. In the second case, freon, butane, propane are used as a working medium. And in the third case, we are using ammonia and the water mixture as the working medium, heat source. The black diagram, if you look at the black diagram, the heat source, it may be from various sources, and it will come to the boiler. That flue gases will convert the heat into superheated steam, and it will get separated in the steam separated, that is moisture will be separated, steam alone will be going to the turbine. The lean mixer, that is some moisture and steam, will go to the brain heat exchanger, where the moisture will be removed and sent back to the boiler, and the pure steam alone will be going to the regenerator, and it will go to the condenser. So at the different sources we have different coils, and that's why we are saying this is somewhat complicated than earlier ones. This is also used in geothermal and other applications. The same working medium, but here we have neogen, that is small in size. It is not much complicated as ammonia water mixer, but it is somewhat simplified cycle than Kalina cycle. Here it is 15 to 20% efficient than ORC because of its simple configuration, but it has a limited applications. It will work between the range of 850 and 800 degrees Fahrenheit. It relatively moderate cost per kilowatt capacity, and it requires less number of heat exchangers than compared to Kalina system. So if you look at this diagram or layout, we can understand very limited number of heat exchangers in this ammonia water neogen system. In all the systems and all the four methodologies, we have the heat recovery, high pressure expander, low pressure expander, and medium temperature recuperator, that is heat exchanger, condenser, pump, cooling tower. All those things are common thermo components. Next one is thermoelectric power generation. Even though it doesn't have practical applications in many places, but it is a concept working on thermoelectric, that is a solid state device which converts the heat, that is a temperature difference. It works on the principle of a temperature difference. It converts the heat directly into electrical energy. It uses the working medium as the waste heat of the gas turbine diesel engines for power generation. By operating this at a higher temperature, we can increase the efficiency of this thermoelectric power generation. When electrical conductor is exposed to thermal gradient, that is a temperature difference, by heating at one end and maintaining the temperature, lower temperature at the other end. One end is at high temperature, other end is at lower temperature. It will generate the voltage hot and cold, between hot and cold ends. That's the concept of thermoelectric. It is very similar to thermocouple, in which thermal elements are made up of semiconductors P and N. If you look at the diagram, you can understand that P and N diodes. The residual heat is supplied to the hot junction, and the heat is removed from the cold junction. Because of the temperature difference, small amount of electric current will be generated. So these are the four methods of residual heat recovery. So thank you for watching this video. Thank you.